Hey guys, this is my second try as usual. Welcome back to my channel. Today is um the 42nd day of my algorithm challenge, and today we're going to explore the multi-dimensional problem from dynamic programming. So there are two cases, usually one in which there's only one state variable. So in that case, we have only defined state variables such as an index to go along the array. This case, we have more than one state variable, and we're going to go through it um, uh, by explanation. With an explanation, let's look at this question. So given two strings, text1 and text2, we have to return the longest common subsequence. And there's no common subsequence, we have to return 0. And the logic is pretty simple. You can see the test case 1, where text 1 is ABCD, text 2 ACE. You can see from the naked eye that A, C, and E is the uh, common letters from these strings. And because length of AC is 3, we have to return output as 3. If we look at test case 2, it's a similar thing. Text 1 is ABC, text 2 is ABC, so they're the same. So automatically the answer is ABC. So length of the ABC is 3. So it returns 3. Now that we know the logic and we know what it needs, what we need in order to solve the dynamic programming, right? So we need three things. First one is we did this yesterday. First one is the base case, when it will fail or just automatically success. The second is the most important recurrence relation, the relation in between the amount of the state variables that's applied to the array. Third one is what was the third one? Yeah, just the state variable itself and the function that it's going to use. So let's do that one by one. Let's just go through it one by one. So first of all, for the function, we know that we need dp. We're going to still use dp function, and there's going to be two state variables. The reason being is that there are two texts that we have to go through, that we have to resolve. And in order to do two strings at once, we need two state variables to go alongside the array. So that's why we have dp I and j, which would return the length of the longest common subsequence when we start at the ith element of text 1 and jth element of text 2. So we have that. Now we need the recurrence relation as well. So what would be the recurrence relation? There are two cases. So first of all, it's when it matches. Like this. So it's when text I is equal to text 2j. So in this case, we have found the matching characters, and we should use them to increase the length. And after matching the characters, we need to move to the next character in both strings. So that will be done just by adding 1 to each of the state variables, right? So that would be dp ij equals 1 plus dp I plus 1 j plus 1. Yeah. So there is no point not using a match, because we can't increase our length by more than 1 at any given step. And the second option is when the character doesn't match with the state variable of the other string. So that's when text I is not equal to text to j. So from here, we can either move to the next character in text one or move to the next character in next two. So we can have two choices, right? So in this case, we're going to do dp ij equals max of I plus 1j and dp ij plus 1. So these form our recurrence relation. What would be our base case? Base case. So base case is when it immediately fails. And we know that the function will immediately fail if one of the text strings gets exhausted, right? So when we iterate through the text, it gets exhausted and there's no more elements to explore. So in that case, we are going to return 0. So we define that as base case. Now let's try to write the code and see how it would work. Uh, First, we're going to use the 2D DP table where we're going to use DP I and J, where we will store the length of the longest common subsequence of the first I characters of text I and first J characters of text 2. And this table will have n plus 1 rows, right? N plus 1 rows. I should have explained this when I was going through recurrence relation. Sorry for this. N plus 1 rows and n plus 1 columns, where m is the length of text 1 and n is the length of text 2. Also, I'm going to use the bottom-up approach just so that we see the more efficient solution. Okay, so how are we going to code this? Is we're going to first define m and n. So m n equals length of text 1, length of text 2. Now dp is equal to this m plus 1 times m plus 1 dp table initialized to 0, right? Just like we did yesterday, we have to initialize it with 0. So that will be 0 times n plus 1 for in range m plus 1. Whatever the length of m plus 1 is, till that length, the length is not important, so we just put it as a this underscore. We're gonna fill up that 0 times m plus 1. Okay, now we're gonna fill up, since we already initialized, we're gonna fill up this dp table by using a for loop, and that will be done by for I in range 1 to m plus 1. And for j in range I n plus 1. I know that it's already n squared time complexity, but this is how it has to be done because there are two state variables. Okay, so first recurrence relation. So if the character matches, if text 1 j minus 1, no, I minus 1, right? I minus 1 equal to text 2 j minus 1, then so dp I j is equal to dp I minus 1 j minus 1 plus 1. If it matches, we just move on to the next variable, or else if it doesn't match, then we're going to fill up the dp table as maximum of the function I minus 1 j. So we if it doesn't match, we either go one step further in text 1 or we go one step further in text 2. So that is done by dp I j minus 1, right? And then now we return the length of the longest common sequence, which is dpmn. So that's return dpmn. And let's see if this works. Okay, parenthesis does not match. We need one more parenthesis here. Oh, come on. Length takes only one argument. And oh, yep. Matched. Yeah, that's wrong. Int object is not subscript. -1 close bracket. Matched. We delete this. Didn't I write maximum? Yeah. Sorry guys, lots of mistakes. But I guess this is crucial for, yes, it worked. Guys, I have to tell you guys, I didn't solve this myself. It was too difficult for me, so I went to the solution and tried to understand the logic and then implement it myself. But I'm glad to see it does work, and I feel like I can do another one if I get used to it. Anyways, that was it for today, guys. Thank you guys all for watching. And tomorrow we're gonna end the dynamic programming series. And after that, we're gonna maybe look at all the templates that we have done so far, and then um try to remember it or recall it. So I think that would be pretty exciting for us as well. Anyways, thank you guys all for listening, and I'll see you guys tomorrow.